Assalamu alaikum. This is my sales presentation, which for the modeling in Caesar. Of course, you will not be professional to do analysis. I'm just telling you how to move your hand inside the program. I will give more examples by time, and every time I'm doing a presentation, I will show more how to model, and I will explain more how to interact with the program. In this session, I will explain how to read the output of the Caesar and how to read it as a stress analysis engineer and what we care about it. Also, how to create the report and how to create the customer report. Let's getting started. This is the output report in Caesar. First of all, it divided to four categories: the load case analysis and the reports, the computed reports, which is the input data inside the Caesar, and this is the reports for the hangars, designed hangars. And the fourth is the exporting window where we export the report. Also, we have here it toolbars where you can change the name of the load case. You can change it based on, if you remember, we named them while we was setting up the load cases. We gave them a name, so you can show it with a name. I use this. It's much better and easier than this one, because this one may confuse you if you are not used to read it like this. Also, you can make a selection for the node how to be shown, where it will be shown. It will be shown in these two tabs. Also, you can give a title for a report, name for the report. It will be shown in the output report. This to go back to the input file. These two tabs I will explain to you while we are going through the results. This is to export the data, and this to print the reports. This is to show the report, this reports on Word or Excel or on the window. This is to set up a customized report. Okay, let's get things started. Once we have the report issued, output report, first of all, we go through all the load case and we make sure that we don't have any red flagged cases, which mean that we are overstressed against the code requirement. Usually you will find it in the expansion, because this is the part where we make a thermal study, or in the occasional. If you have problem here, that's mean that you have problem with the support configuration. Okay. First of all, let me remind you with our model. Go to the input. I will show you our model just to remember. This is our model. We run here the flange check, okay, and we also run here the nozzle check limit. If you forget how to do this, it's easy. We are using a pump, so you just select this one, going to this tab, nozzle limit check, and telling them I need it absolute. The pump, usually we use the shaft. We are going to parallel to the shaft to make our vectors. So parallel to this is the discharge of the pump. So the shaft of the pump will be in the horizontal, in the X direction. So we select X direction. And we can open here and use the API data. I will ask the type of the nozzle, telling it stop to press OK. It will give you the maximum of the code API 610. This is just a check, a primary check. This is not the check of the pipe of the pump. Make sure of this, just a primary check. Okay, let's go back to the results. Since we have a flange check, what we first do, we will go to the operational condition, load case, and go to the flange check. Before I would start doing this, I will go through this report. This report for the displacement, these two reports are the restraint. This is just the forces and the moment. This the forces and the moment with the displacement on the supports. This is local restraint. We have a global axis and we have a local axis. Local axis means that let me go here. This is considered a global axis, but if I took this and put it here specifically on this load, maybe the axial will be in this time, the axial will be in the y direction and the circumferential will be in the z direction and the longitudinal will be in the x direction. This will be considered local. So globally, it's different than the local case forces. Uh, this will be explained more when we go to the nozzle analysis, because in the nozzle analysis we have this local conditions. Uh, um, and we have here the strain load summaries. This is if we summary is if we use more than a load case, it will be shown here. Also the same. This is forces and moments, and this is with displacement. This is the nozzle check based the one. If you remember the one we just activated, this is for it. This is the flange check as per the P16.5. This is as per the nuclear code 3658. This is the global forces based on the axis of the global forces. This is local forces, and this is the stresses against the code, this three, and this is the summary for the maximum stresses. This is the code compliance report. What we first do, uh, as I told you, I'm checking if I have anything over stress. If I don't have anything over stress, I go to make the frequency check. The frequency check I go using the normal operating condition and check the flanges if I have over pressure. Here I will have an overpressure. I know that I leave it to show to you. See, the numbers is big. This big numbers means that we select the number of ratios, select the wrong flange rating in case the material engineer was mistaken. Uh, why this? If you see the allowable pressure is 12.10, while the equivalent bar is 70 and 63. This is too much difference. Usually we selected 80% of the pressure or should not go above this. So this means that we have the wrong flanges. So what we need to go, we go back here and we select the flange and go and raise the flange. I think we will use 900, 600 class 600, and for carbon steel. Same here. We'll apply it to all the flanges. See the difference? We are using 25 temperature 25. Here's temperature is 83 point, the pressure is 83.5 bar, while here we are using 50 bars. The other one we was using 12, which is great difference. So we are already above the limits of the flange. I left this to show to you that this is one of the flange rating check. Okay, let's repeat the run. See, it's all safe. This is over. This issue it should be going down because, as I told you, the issue should be below 80. Usually, it should be below 80. In some cases, we can keep it above it if the system is too rigid. After we go in with the same operational case and make a nozzle check. Okay, we are above the limits of the nozzle check. I will show you how to save it, but not right now. After we go with the displacement, we need to check it against the operational and the design, but mainly with against the operational. So you open it and make sure that you don't have any displacement in the dy direction more than 6 millimeters without any reason. Sometimes you have a reason, but you should not have any 6 millimeters nodes inside this. And this is what we call sagging. You don't need to have a sag uh, between the supports. Make sure from something. Take care from something. This is a beam analysis software. So between these nodes, he don't consider any node. So if we need to study any node, we need to break and make a point in between them. This, for example, to be shown and to be studied. If you don't have a node and you have a sag in the middle, you will not find it. So you need to put a node, extra node in the middle. Okay. For example, here, if you see we have 10, 16, and 19, this is because we have upward, because we have springs also. So we have upward displacement. Here we have in the 70s and 75. Let's see. You don't need to go every time to the input. You can just press here and open a 3D model to show you the output on the 3D model. We select the operational case we need. We use the operational case number 1. It will open the report. And we have in this report the stress, the high stress, the displacement. What we need is the displacement. And here we have 11 millimeter. We can keep it this way because this will be connected to the tank. So we don't need to transfer all the displacement to the tank. It will be already have high stresses. Already, I think we have a high stresses in this point. Yeah. We will see this in the restraints. See, I will solve this later in the presentation for the tanks. And this coming because we have this support as a rigid. We can, in the case of tanks, we can remove this, either we remove this support or we put a spring. This depends on the tank. I will explain this in the presentation for the tanks. So this is a way to show the results in the Caesar. You can even press this icon, it will show you the deflection. You can increase the magnitude of the deflection or decrease it. Here he will show you the maximum forces, the maximum stresses. If we have, and here we can show you the maximum displacement also in the dy, for example. He will show you this one. He tell you that this one is the maximum displacement. Uh, we have a maximum displacement here. Okay. Let's go back to the output. You can run the output report without running the analysis from this icon. Also, in this check is coming by for the displacement is coming by the sustained operational sustained, not the sustained load case. Sorry. And for the displacement, you need to make sure that you don't have more than 20 millimeters without any reason in the horizontal directions. Okay. Uh, and in the restraint load summary, I usually use the restraint summary extended. You select all the operational cases and press to show. This is a summary report, so it will show you all the cases for every node, and it will show the maximum here. Make sure when you run this that you don't have any positive Fy unless you have a spring. Okay. This is of course the rigid wide 500. The anchors for this for the spring. This is the anchor for the pump, the third pump. If you have any stresses, you will select this and press the stress report will open. You can double stress the ratio. It will give you the highest ratio. But we don't have any stresses here, so it's okay for us. But I'm just showing you the report. This is the main reports that we are using. Also, if we have a hanger report, you need just control remove it and press here. If you need to see the hanger report, this is the hanger select based on the anvil. He will give you the type, the figure based on anvil, the vertical movement, the hot load, the installation load, which is the cold load, the spring rate, and the horizontal movement. I'll explain this in the hangers presentation. If, for example, I need to have the displacement for all this load case. Uh, if I run the report here, it will give me every displacement load case separately, and this takes time, as you can see. It will give it to me separately. So I need to make a custom report. In the time we will go to this tab, I will just stand on the displacement. I will go press this icon. The customized report will be open to me. Ask me what you need to name this template. I will tell this summary. And you need to change the report from individual to summary. Now we are using the displacement code, so we need the data inside the displacement code. So we go to this report, open the displacement. In the DX, you need to select in which column you need to be located. So I mentioned I need it in the first column, in the second column, and so on. As you can see, every time I updated, it will show me the column how it will be shown. Okay, now I need to save it. You just press save here. It will ask you how you need it to be shown outside in the report. Press OK. Now it's saved. You will find the customer report that we just created here. You press selected and you select the load case, all these load cases, and press show. It will show us for every node the displacement based on this load cases that we select. And this is how we can create a summary report for any report that you need. And this is how to customize the report. We can edit it even after that. Okay, now how we give the output report. The output report, first of all, we select the input echo. What is the input echo? The input echo is a report that show all the input that we give it to the that we put it inside the model while we are modeling. You can see it mentioned the temperature, the pressures, the seismic, the material, the wind, that shape, the allowable stresses. Every data we need to know about the input or the setup of the model, you will find it in this report. So you need to add it here. You just press added. Also, in the report, we give the displacement. The displacement is based on all the operational case. Okay. If you need to move any of this, you just select it and press move. Okay, we just don't need this, so we remove it. After, we need to put the restraint load summary, also the restraint load summary for all the operational case. Okay. Now we need to give the stresses. So the stresses is not coming for these cases, it's coming only for the occasion and the expansion cases. Okay, after that, we need to show them that the nozzles and the flanges are okay. So you need to press this and you need to press this. And in the end, you need to give the report for the hanger selection. And press word and press finish. And this will give you the report. Before I finish, I promised you to save the nozzles. So let's try to save these nozzles. I think we can save the nozzles by removing the gap and removing this guide. Let's try. Okay, we'll make it worth. Let's try to get the gap. Yeah. We reduce the force, but we increase the moments on the B. We have extra force here. As you can see, by the way, this is the axial, this is circumferential, and this is the longitudinal. So if we consider this, I think this will be the moment around the X. Let's remember 10,052. Let's go here. Yes, as I told you, the moment around X, since this is the maximum. So this is how you can correlate between the local stresses and the global stresses. Let's go back. You can remove this guy. Yeah. Okay. Anyway, this is just a model. This is not the right model, even because if I need to do the stress analysis, I need to reconfigure this model anyway. This is how to read the report, and this is how to create the report. In the end, let me do it to you again. You will edit this, edit this in the displacement. And the restraint load, we will add this. In the stresses, you will add this part. And you need to put another check under the operational case. And check under the operational case. And quote. In the end, you'll select Windows, Microsoft Words, and press Finish. It will ask you the same as for the input echo. You press OK, and you'll find that the Word will open and start to print your report until the end. Don't overload the system with all this load case, because eventually it will be hanging up. And take care while the reporting is working. Try to reduce your work on the computer, because it may and especially on Word, because it may hang up the report printing. I hope this was helpful, and you understand how to create report and how to read the report, and how, as a stress engineer, we are looking on the report. If this last three presentation was helpful, please subscribe to my channel and press like and the notification to follow me up for the next presentations, where I will explain more about Caesar and how we do the stress analysis. Thank you for watching.